ஸ்டார்ட் பண்ணி விட்டுறேன். Hello, good evening to everybody. Let us start the webinar. Dr. Sami will be handling this session. We will be covering you today NFPA standards and the fluid mechanics. Good evening to everybody. Let us start the webinar. Dr. Sami will be handling this session. We will be covering you today NFPA standards and the fluid mechanics. Dr. Sami, you can start the webinar.
Hello, good evening all. Welcome. Assalamu alaikum. Marhaba. Already?
Doctor, you can start the webinar.
Okay. Today's free webinar for mechanical exam. Firstly, I will introduce myself. I am Dr. Muhammad Sami. I have a PhD in mechanical and also master for business administration. I am a professional trainer for UPDA and working as an assistant professor in mechanical engineering department and also deputy mechanical manager for consultant company. I have a grade A for UPDA. Our agenda today, we will start by general introduction about for the all topics coming in the exam and what is the exam, what is the type of question coming in the exam, what is the exam structure at all. Then going in some specific topic, today we will focus for overview for NFPA standards and part of fluid mechanics like continuity equation, energy equation. Also, we will going to solve numerical problem to know how to solve these problems. And during solving and after that, we will discuss some tips and tricks for mechanical exam related for numerical or general question like theoretical questions. And going for discussion about for what is the exam frequently questions and important formula sheet for the topic discussed today. And at the end, we have some time for question and answer part. For anyone need any questions, this open discussions. Okay. Starting by introduction. Actually, the exam for UPDA mainly focus for three parts. These three parts is a part for the exam itself for mechanical, this is our discipline, and other part it is for PMB, and also the third part NFPA and some special general questions. I will tell you what is the general questions. The exam it have 25 questions. The exam is consist of 25 questions. Okay, this 25 question normally it is divided between these three gears, three branches. For mechanical, normally it is from 15 to 20 questions coming. For BMB, it is 3 to 5 questions coming. And NFPA, around 2 to 3 questions and 1 general questions is coming. For example, if the exam coming have a 15 question for mechanical, maybe have a 5 question for BMB and 3 question for NB and 1 general question, something like this. The total is 25 questions. So sometimes it is increased between these 15 to 20 questions. Normally PMP is asking for theoretical, but one of these questions, at least one, it's coming numerical. It's asked for theoretical questions and numerical. Okay. For general questions, maybe this question related for electrical department or civil department, but the idea for thinking for these questions is related for mechanical at the end, related for mechanical. Okay. But NFPA, this is directly related to NFPA, for standard code of NFPA. Okay. And not only the NFPA related for fighting or for mechanical, no, is related for general NFPA, for mechanical, for electrical, fire alarm, firefighting, fire safety. We focus for firefighting, but many questions are coming also for fire alarm and mechanical ventilation. Some small question related for fire safety, but asking also for sometimes for fire safety. Okay. For mechanical questions, around 70% questions, it is numerical. Before, from all time, actually 10% is numerical, but recently now, number of numerical question is increased. At least 7 questions, 8 questions minimum numerical questions. It reached up to 12, 13 questions, something like this, sometimes. Okay. Now the number is the examiner for MMUP, it is focused for numerical problems. Okay. How to pass for this exam? Actually, we need from you to pass only 50%. 50% correct will be passed. 50% it means we need 13 questions. Okay. 13 questions. Okay, pass. If this is correct, pass. Okay. Any question wrong, it is not counted by minus, something like this. No. If it is correct, it's counted take point. If it's not correct, it's cancelled. No problem. Okay. Don't keep any questions without solving. Solve all questions, whatever you know or you don't know. Okay. It means at the end we need 13 questions to be passed. As you see, it is easy. 13 questions. Yes, it's easy, but need to prepare, need to study, because at the beginning of the exam, by the way, the exam is 1 hour. At the beginning of the exam, you feel you have a lot of time, and you start the exam to solve one by one. But actually, once you pass 10 minutes, around 10 minutes, you will solve around 5 questions at the beginning. Okay? Be careful for the remaining time to be compatible with the questions. Okay? Manage your time with the questions. Don't go in depth and lose time for one question and forget the others. No. At the beginning of the exam, just going to the exam, start, follow for all questions, 25 questions, all at the beginning. The exam, the 25 question is coming 5 question per page. Okay, you're going page by page, 5 question here. Okay, you can solve 1, 3, 4, finish. I can't solve now number 2 and 4. Keep it, no problem. Not now. Going to the next page and third page and fourth page and so on. 5 page finished. At the end, you found you solved 7 question, 8 question at the first round. This first round almost take from you 10 minutes. Okay, after that, the remaining 50 minutes, distribute this time for the remaining question required to be passed. Okay, be careful for the time. Manage time is very important. Okay, actually, the exam is online. It is by PC. This is a PC monitor. At the top here, you found some bottoms. Okay, this bottom is equal to 25 bottoms. Same number, the number of questions. Okay, after you finish first page, this 5, going to next to the second page and so on, next to third page and so on, one by one. Any question you solve, for example, you solve it number 1, this one, you will see this color is changed to be gray color, shaded color. For example, you solve number 3, okay, this number 3, you found number 3 here is shaded color. You solve number 4, okay, you found this one shaded. After you're going page by page, at the end, check this bottoms here, this is squares. Any one shaded, it means it's solved. Anyone not shaded, it means not solved. Okay, I need to solve the other problems not solved before. Just press the question direct. For example, press number 2. You will go back direct to page number 1, question number 2 here, which is including to this one, yes, which is including to question number 2. For example, I press this button for question number 8 because not solving. Press 8, you're going to direct to page 2, which including problem number 8 to solve direct. Okay, this is what you will find at the exam. Everything is not allowed in the exam except calculator, and this is not your own calculator, this PC calculator. Okay, I will check with you how to manage this also. It is, if you don't see before or not make training for that, it is difficult for you if this one first time to use it or to open the calculator for the PC. No, it's so difficult to solve the problem and make calculation for this one. Okay, training is very important, please. So continue here. What is the topic actually for mechanical? As you know, the mechanical have many topics, and almost all these topics, it is covered in the exam. Sometimes the exam, it is focused for 2-3 discipline or topics in the exam, but sometimes it is general, it's coming from different topics. For example, sometimes it's focused for HVAC, for thermodynamics. Sometimes it's focused for stress analysis only. Sometimes it's focused for fluid mechanics. Sometimes it's balanced between all. It is not a standard for the exam. Okay, so we need to cover and study all important points for all topics in mechanical. Not going in details, we will focus here for the important thing related to the exam direct. What is the important, what's coming in the exam for each topic, and we will study this and make refreshment for this one. We will go to make refreshment by theoretical principles, and we will make a remind for the equation used for this part, and we make also some practice theoretical questions and the practice numerical problems. Okay. Actually, one of the major topic important for the exam is fluid mechanics. This is one of the major topic. Our points here, including in the topic of fluid mechanics, we are going to first for some definitions important, and we will go to describe the state of matter, then viscosity and vapor pressure, cavitation, surface tension, pressure. Here, as you know, as you see here, some items I make a bold for these letters. It means this very important unit inside this topic. Very important to be understand this topic, to be aware for all ways for this thing, because the questions coming for this part, for example, a lot. Types of fluids, and we going to classify this fluid: laminar and turbulent, viscous and inviscid, compressible, incompressible, steady, unsteady, uniform, non-uniform, and what is the different concept between steady and unsteady and uniform, non-uniform. Many confusion for this point, especially rotational flow and irrotational flow. Also, continuity equation is very important equation, and almost no exam coming without this equation. Bernoulli equation, energy equation, head losses calculation, buoyancy force and stability of the bodies, compressibility and incompressible flow, viscid and inviscid flow, some important numbers. I know almost know Reynolds number and Mach number, and I know also many engineers don't know about Freud number. We will study also this is coming in the exam. Intensive and extensive property, differential pressure meters. Almost this is the part for fluid mechanics. Then we're going to application related for fluid mechanics, and this application is very important, is pumps, and we're going to everything related for pumps, classification of pumps, dynamic pump, displacement pump, pump selection curve, and net positive suction head calculation. One of the important thing is coming in numerical theoretical at exam. Affinity law, also it's coming post numerical questions and theoretical questions. What is the meaning of volute, priming, cavitations, and so on? Some important phenomena happen in pump. Pump efficiency, how to calculate pump efficiency, and also general efficiency. What is the concept of efficiency? Any efficiency, how to calculate this efficiency, whatever pump or another. Third column here, talk about for another big topic and important topic in mechanics, thermodynamics. Thermodynamics, as you know, it is very important fundamentals for mechanical department, and also this is one of the famous questions coming for the exam. Here we will going to study the meaning of pressure, volume, temperature, work, heat, force, power. What is the relation between all this? Thermal energy and temperature. What's the difference between definition for each one? Thermal equilibrium and the Zero's law of thermodynamics. Types of system: open system, closed system, isolated system, insulation system. Gas laws, same like Charles' law, same like Boyle's law, same like Gillis's law, and also another. Dalton's law, kinetic theory, for meaning of elastic and inelastic. What is difference between elastic and inelastic collisions? Joule's law and including internal energy and enthalpy function related to ideal gas direct. Also general gas constant, and the confusion happen all the time between the universal gas constant and the specific gas constant. Avogadro's hypothesis, and first law of thermodynamics, second law of thermodynamics, and what is different between these two type of processes, like isobaric process, isothermal process, isentropic process, adiabatic process, and other processes related for thermodynamic. Specific and heat capacity. What's meaning of specific heat and what's meaning of heat capacity, and difference between this one and what we will see in the part of heat transfer for the effect of thermal conductivity and the specific heat. What's the meaning of each one? Each one controls something. What's different? Volumetric and gravimetric analysis, homogeneous, heterogeneous system, water properties. Water properties, Carnot cycle. There's a one start to the topic of power cycle. Carnot cycle, actually, this one, it is the highly efficient cycle. This is the maximum cycle we can obtain efficiency for this one. This is the maximum efficiency for Carnot cycle. The ideal one we can mention for this one as an ideal one. Heat engine, external combustion engine like steam power plant, Rankine cycle. We study this cycle in detail. Internal combustion engine like gas turbine, same like Brayton cycle. One of the important and the famous question in the exam, Brayton cycle. It's coming a lot. Reciprocating like petrol, diesel, which is under the cycle of Otto, diesel, and Dewey. Compressors, some indications for compressors and reciprocating compressor. Jet engine like turbojet, ramjet, scramjet, turbofan, turboshaft, turboprop jet. Small information for each part. Air to fuel ratio. Reversed Carnot cycle. We start by Carnot cycle to study the ideal cycle for the forward one, but we're going to study also reversed Carnot cycle to study the reversed cycles. Reversed Carnot cycle also is the ideal cycle and the maximum efficiency for the cycle for reversed one. Reversed Carnot cycle and reversed Brayton cycle. Reversed Brayton cycle, actually this called as air standard cycle for refrigeration. Air standard cycle for refrigeration. Also, this important cycle for refrigeration. And how to calculate COB, absorption refrigeration cycle. Normal refrigeration cycle is stoichiometric chart. As you know, all you know now, the stoichiometric chart and the importance for this chart for mechanical, for the part of air conditioning, and how to use this stoichiometric chart. What is the parameters control for this one? Dry bulb temperature, wet bulb temperature, relative humidity, humidity ratio, enthalpy, which is one of the important parameters talk about for the refer to the energy for any point. Process for the cycle of stoichiometric chart, like sensible cooling, sensible heating, like humidification, dehumidification, all this process, and combined between these processes also is coming on the exam a lot. Understanding for different type of HVAC, and we'll go to simple simple descriptions between DX system, which is direct expansion system, and chilled water system. Then we're going to some elements related for HVAC like fire damper, volume damper, splitter damper, condenser, one of the main elements for this cycle, evaporators, cooling towers. Another topic for mechanical, heat transfer. Actually, heat transfer, we start this topic by questions which why we study heat transfer and difference between this topic, heat transfer, and another topic we studied before for thermodynamics. And then going to the important things for heat transfer, like what is the mode for heat transfer, conduction, convection, radiation, equation for each one used for the exam, and the numerical applied problem for this part, heat capacity and specific heat capacity, latent sensible heat, what is meaning for each one, insulator material, and this normally one question for the exam coming for insulator all the time, heat exchangers, boilers. Another different topic is stress analysis. Stress analysis. This topic, it is very, very important actually. This topic, it is very, very important. Actually, all topics before is mainly focused for power, mechanical power. But this one is focused for production mechanical or mechanical production. Sometimes the exam, it is not have many questions for this part, 2 questions, for example, but sometimes the exam focus for these questions, at least 5-6 questions numerical, only for stress analysis. Also be careful for this part, because this part, almost all questions is not given in the exam, because all equations is not given in the exam. Because the equations here for this topic, for stress analysis, it is a small equations relation between 3 parameters. One parameter is equal something times something. One parameter is equal something divided by something. That's it. This is the reason for the problems numerical for this part. Normally, equation not given should be saved. Okay. For this topic, stress analysis, we will focus on stress definitions, types of forces like normal force, shear force, type of stress, normal shear stress, bearing stress, types of strain, normal strain, shear strain, Hooke's law, one of the important questions coming a lot, and elastic plastic behavior, ductile and brittle material, fatigue, impact, hardness tests for all, Poisson's ratio and how to calculate this part, what is the equation for Poisson's ratio, and going to support types and reactions. As you know, all you know the types of reaction. According to the type of reaction, type of support, we found the number of reactions. Some of supports have 1 reaction, some of supports have 2 reactions, some of supports have 3 reactions, X, Y, and moment. Force and moment equation. Then going to bending moment diagram, shear force diagram, materials, welding. This is mainly the equation coming a lot for this part for welding. This is the part for stress analysis. So we're going after that to discuss another topic for NFPA. We will go to study NFPA codes, all codes related for fire safety, related for firefighting, related for fire alarm, related to mechanical ventilation. We'll cover this one also for NFPA part. And especially for, as you know, for fire alarm code have frequently inspection and test for many equipment and many question asking and focus for this part. At the end, now we discussed 2 gears, one of the mechanical and one for the NFPA code. We still have 1 gear not discussed, which is this one, this BMP. Okay. BMP actually this is important topic because it is including from 3 to 5 questions. It is not small questions. It is percentage for the exam, and this part, the numerical part and theoretical part, it is better to be study well, because the question is coming repeated normally. So it is focus for this part to be easier for you. Okay, this PMP part. Finally, for the introduction, be careful for some small things like units. I repeat all the time for sessions, units, please. Units, units, units. All study by standard units all the time. Normally study by standard units, same like SI units. But actually the exam, it is covered by not standard units, not like British unit. Actually the exam, it's coming normally by British unit. Okay, and in this case for units, you have two ways. First way, to change the unit of the problem from SI totally to be from British to be totally SI unit and solve it by SI unit. But be careful, because this way take time, and normally exam calculated by the time of British. Okay. Second way, solve it by British unit as it is. Okay, but what is the problem for this? The problem, some tricks and tips for solving. One of this, for example, the problem, during solving the problem, equation have one constant, for example, easy equation. So, for example, if I write the easy equation like, I write it here, B equal rho G H. Okay, actually here, this what B, very easy equations, very, very important problem, and the equation very important. Okay, this P pressure is equal to what? Is density, 3 parameters, G is gravitational acceleration, and H, which is height. If I give you height and I give you density as a problem, what is G? What is G? It's not given. Gravitational. If you don't know the value for the G by British, you don't have any option. The only option you're going to change the units for the density, change units for the H, for the height, and this takes time. So it's better to save G. As you know, many problems, many equations have G. So I save this one, 32.2 feet per second square. So if I save this value, I save time a lot. Okay. This is the first thing for units. Okay. Other thing, calculator. Calculator important. Why? Calculator, if you don't make a practice for calculator, you lose a lot. If you use calculator first time on the exam, you lose a lot. Why? Actually, the calculator part, the calculator we used on my hand is easy, but for the calculator in the PC, should be know the tricks for this one. Normally, all have computers for Windows 10. Okay, almost. So this PC have a calculator, and each one have how to use this one, and I will tell you how to use this one here. Okay, but sometimes some of the PCs in the exam, the Windows is not Windows 10, older version. So the calculator, this old version. This old version calculator, it is not same like the default. So once you open the calculator for the old version, you found something like this. Okay, when you open. Okay. And only this monitor for the calculator and these numbers here. Number. If you keep it like this, you can't solve anything. This is standard. It's like you need to add some values, multiply some values. So what do? You here, you found something mentioned file or view. This view, press view. You see menu. Once you press view, you see menu. Actually, you will found is mark for standard. This is standard actually, what you open. Okay, what you will do, just mention for scientific instead of a standard. Select what? Scientific. You will found this one extended like this. Okay, you found this one extended like this. So what happened for extension? You found here squares, root, log, many things for scientific. Bracket, sine, cosine, everything. Is enough? Not enough. What else? You will go in this menu down. You will find other thing here is mentioned is unit conversion. Unit conversion after basic. It's mentioned by basic. No, mentioned for unit conversion. You will found other extension here for the calculator. This other extension mentioned for the what you need to be converted. First conversion to the second. What you need to convert to. For example, here lens. Select lens from the menu, and you found here different units for the lens, different units for the lens from 2. Without this change, you can solve anything. Okay. For the calculator for Windows 10, I will see you here after I finish the introduction. Okay. Finally, study hard and relax. Okay. Going to the second part. Just wait. Okay. Second part here after introduction. We're going to the in details for the topic today. One questions. Today we will discuss about for overview for NFPA, and also we will discuss for overview for fluid mechanics. We select some topics for fluid mechanics. Okay, we start by NFPA. Actually, NFPA codes important for the part for the mechanical exam. As I said, some this codes related for safety is important. Some of these codes related for firefighting, some of that related for fire alarm, and also for mechanical ventilation. Okay. Actually, we will go to make a quick review for the important codes coming in the exam. For example, NFPA 1, this fire code, NFPA 10, this for portable fire extinguishers, NFPA 13, this for sprinkler system, NFPA 14, this for hose reel and standpipe. Also 20, this for stationary pumps. 22 for fire tanks, fire water tanks. So from 10 to 22, we are going to focus for firefighting. 10 to 22, 10, 13, 14, 20, 22. All this related for firefighting. Then going to 70 and 72, related for part of electrical and fire alarm. Electrical, this 70, national code for electric. And fire alarm, this NFPA 72. Okay. Then going to another part related for mechanical ventilation. For the part of mechanical ventilation, this 88A and 88B, this is related both for one of parking and one for garage. '92 and 92A and B divided to A and B, but mainly focus for 92 for a smoke control system, smoke management system, smoke control system. 96, this related direct to commercial cooking operation for both mechanical ventilation and fighting, but mainly the application for 96 for commercial cooking. 99 is also focused for application for healthcare facility. This mainly the topic, healthcare, whatever related for mechanical ventilation, air conditioning, change of air in hazard area for healthcare, firefighting, and so on. 101, this one of the famous and important code for standard NFPA. 101, life safety code, life safety code. 170, this is related for the symbol and fire safety emergency symbol. This is not important, but just I mentioned for to be aware for this. 203, this important. This also related for mechanical ventilation, but special design for this related for natural ventilation or smoke vent. 2001, this mainly related for clean agents, same like FM200, which is used for substations, protection of substation. 5000, this building construction and safety code. This is a tool, building construction and safety code. Okay, going to some relaxed questions. Okay, first question, testing of water flow device. Answer, please. Share with us. Just you can write your answer on the chat. Testing of water flow devices. Okay. Share other, please. Okay. 3 C's and 1 B. Okay, check the answer now. Answer is quarterly. Testing of water flows device is quarterly. Means is answer is B. Okay, going to another one. Answer please. Kindly all share please. Visual inspection of supervisor signal device. كله all focus for semi-annually. No, monthly it is far. We have one specific monthly is coming a lot. What else? No more? Okay. Quarterly. Talk about here for visual inspection of supervision. Visual inspection, not testing. Not testing. Be careful for this question for the starting. He asked for testing or asked for visual inspection or frequently inspection. NFPA code used in car parking as B. C. B again. Okay. And so, okay, almost correct. Car parking is 88A. 88A. Actually, 1 is fire safety, life safety. This symbol 170, 72 for alarm. NFPA code used in a sprinkler system. All agree here. Yes, correct. Thank you for sharing. Prevents the spread of smoke inside the duct and fire resistance rating from room to room. Which answer is correct? C. I think all is going to correct answer also. Yes. Correct. Fire dumper. The firefighting, all these questions from exam, recent exam questions. Firefighting water sprinklers cover a maximum distance of, read carefully, read the answer carefully, choices carefully. What is that correct? C. Okay. Any more answer? Okay. Actually, anyone, can you write it for this value by meter? By meter, maximum distance by meter. No one know? Yes. Almost 5.5. Its exact value is 4.6. 4.6 meter, which is referred to, when you convert this value, we will The answer is C, 15 feet, equivalent to 4.6 meters. This is the maximum distance between the two sprinklers. This is for light hazard, actually. Okay. Second part here, this is NFPA part actually, and this some questions important for NFPA. Okay. Second part for overview for fluid mechanics. Here I will focus in fluid mechanics for two important equations. First one, normally no exam coming without pathing for these equations. Almost all exams have equations related for continuity. Sometimes is ask direct for continuity. Sometimes one of the steps need to apply continuity, okay, or part of continuity. Okay, actually, what is the continuity equation? Continuity equation by simple definitions, conservation of mass. Continuity equation by simple definition is conservation of mass. Okay. Here, as you see, the continuity equation is consists of three terms. These three terms, this one, first one, d by dt mcv, change of mass in the control volume. Second part, dot out, mass out, rate of mass crossing the control surface. Last term is m dot n, and also crossing control surface. All these terms is equal to zeros. Is equal to 0. Three terms. We will focus here for the second and third term. Normally for the problems coming in the exam, first term considered with 0. D by T mass control volume. Why? Actually, this one is appear when we study system have a variation in the control volume itself. For example, if you study a tank like this, and this tank we have one input and one output for here, input also, and we have one output. This input, this input, this output. Okay, and we have a surface for the water here, and this is a control volume to study. Now, if the m dot n and m dot out, m dot n, not equal m dot out, it means the mass, the rate of mass here, it changed with time according to the unmatched between output mass and input mass. Means this one maybe increase, decrease, not all the time constant inside the control volume. So, but this question is not coming in with this difficulty for the d by to use it d by dt in control volume. Normally this one we consider 0. So the final equation used a lot for continuity and coming in the exam, sum of the mass out, m dot mass flow rate out, is equal to sum of the mass n. We will put this one another side, this one minus this one equals 0. It means this one equals this one. And this applied for all pipeline, because for pipeline there is no accumulated flow inside. Normally anything going into the pipe should be going to out of the pipe. Anything going into the pipe should be going to out of the pipe. Okay, so the equation here used only sum of the m dot mass out is equal to sum of m dot mass in. That's it. Okay, which is this equation. This the important equation should be safe. Very important equation. Okay, and same like this applied problem. We have pipe like this, whatever the diameter change or not, but what we are sure, m dot n equal to m dot out. What is m dot? Mass flow rate. Mass flow rate. Okay. What is the unit of m dot? Actually, the unit of m dot kilogram per second for SI. What other unit for British pound per second? Pound mass. Pound mass per second. Okay. So if the system have a one input, one output, it means m dot n equal m dot out. That's it. If I have a different input and one output, it's okay. Mass m dot 1 plus m dot 2 plus m dot 3 for input, it's equal m dot out. If you have one input, different output, it means m dot n is equal to m dot out 1 plus m dot out 2 plus m dot out 3. Sum of m dot out. Okay. Another thing important for this part, for this equation, as you see, it's a very simple equation, but very important. One of the important thing here, m dot itself. What is the m dot equal? M dot equal, here, just close this first. Yes. M dot equal rho V A, density, velocity, area. Here, M dot, where is it? M dot equal here rho V A. This is the density, velocity, area. Area for the two area here, cross section area. V is volume, velocity from 2. M dot mass flow rate is constant. Yes. The velocity not constant. No. Why? Because velocity is related direct to the diameter. If the diameter it change, it means velocity should change. If the diameter not change, velocity not change. According to what? Continuity. This continuity is that. Okay. We can simplify this equation more. How to simplify this one? Normally for problems, the default flow coming in the exam, water. Or similar to water, incompressible flow. Incompressible flow. And we have one thing in incompressible flow. What is this thing? The incompressible flow density almost not changed. Density not changed. It means the density at the beginning is equal to the density at the end, at the output. So in the incompressible flow, if this is incompressible, it means the density constant. It means I can cancel density from this side with this side and make simplify for this problem equation. We will find at the end AV, A2, V2 is equal to A1, V1. So easy equations. AV equal AV. What is AV? AV is called Q. It's called Q dot. What is Q dot name? Volume flow rate. Volume flow rate. Don't forget this one. This one, what? Q. But if I mention like this happy face, correct? Just I add here A, V. Don't forget this one. I've almost no exam coming without apply for this equation. Happy face, which is Q equal AV. Okay, don't forget, please. Okay, so what is Q alone? AV. If you need to apply for the Q itself, AV. What is the continuity equation if I need to apply? Q1 equal Q2, Qn equal Q out. If you have many input or many output, sum of Qn equals sum of Q out. Okay, what is units? Here units is meter cube per second, volume flow rate, meter cube per second. This is a unit. What is other unit? Here for this one, have a many units, several units for bridge. Same like CFM, and all is famous, especially for the Q. CFM, cubic feet per minute. CFS, cubic feet per second. GBM, gallon per minute. LBS, liter per second. So on, many units for British used for Q. Many units. Okay, and all is coming, especially for CFM and GBM. This is especially okay, and CFS. This the standard used to be converted from SI to direct to uh, here to British, from meter cube per second to cubic feet per second. This is the easier way. Also important here, area. Be careful for area. I tell you one problem, we solve one problem for this one. Area is easy, pi over 4 d square, but I have a big trick for this one. I will tell you during solving problem, apply problem today, what's the trick for this. Area equal pi over 4 d square, related for units, not related for the equation itself, is related for units. Okay. So again, quickly, continuity equation. The first equation is not important to be aware, just at the end, m dot in equal m dot out. And for incompressible flow, Q in equal Q out, Q is equal AV, m dot equal rho AV. One asked me for, it is not important to save m dot and save Q, it is enough Q because all questions are coming for the water. Yes, almost all questions are coming for the water, but sometimes it's coming and we have questions for this. The type of the flow, it is not water. The type of the flow is air or exhaust gases, but consider as air. At the end, he mentioned consider as air. It means is compressible. So in this case, Q it is not applicable to apply, and we're going to apply m dot, mass flow rate, and we put the general equation rho AV equal rho AV. Okay, clear? Okay. Questions here? D is a diameter. D is a diameter. Diameter for the pipe. Diameter for the pipe. Pi over 4 d squared. D is a diameter. Okay. Okay. Give me answer, please. An ideal of no one answer. Share, please. Share. Okay. Okay. It makes sense, yes. Just we finish continuity equation, and so the equation is related for continuity equation. Okay, thank you so much. Going to another lesson here for Bernoulli. This one, another thing is important. I mentioned is energy, but I start by Bernoulli because the Bernoulli is fundamental and many questions coming for Bernoulli alone. Sometimes is including and adding one parameter to going to energy. Energy, it is same like Bernoulli, but Bernoulli it is an energy equation in ideal case. Energy equation in ideal. We can consider as it is. Energy equation Sorry for this missing connection. Okay, I am with you now. Sorry for this connection is missing. Bernoulli equations, as I tell you, this is one of the type of energy, but this is standard one. This is standard one. Okay. So for these equations, firstly, describes the energy along a streamline. Some conditions for this one applied along a streamline. Total energy is the same, is constant for each point along a streamline. It means, for example, if this by, for example, like this, and we have a flow here along a streamline. If we consider this streamline, the energy here, total energy here, is equal total energy here, and is equal total energy there. Okay. What is total energy? What is the parameter referred to total energy? What is this parameter actually? Here we describe energy in three parts. First part is flow energy. Second part is potential energy. Third part is kinetic energy. The sum of these three is equal constant. The sum of these three equal to constant. Okay. If sum of these three is equal to constant, it is, if I study, for example, point 1 and point 2, this point 1 here, for example, this point 1, this point 2. If I tell you the pressure at point 1, x, and pressure at point 2, 0.7x, it means we have a difference in pressure, correct? The flow energy part. As per Bernoulli equation set, total energy must be constant. It means this energy decreased in this part should be increased in another part, should be increased in another part. It means maybe this increased for kinetic energy. This kinetic energy Y here, this kinetic energy other side, 1.2 Y. To be at the end, the total energy is the same. Okay? As you see here on the slide, two equations, correct? Actually, it's one equation, both the same, but different form or shape. Was meaning? In the equation, we can describe this equation in different shapes, in different units. Milli units. Milli what? Units. Be careful. Units. Again, very important thing, units. For first one is in energy form. It means that units for each term is unit of energy. B over rho plus rho gz plus v square over 2 is equal to constant. First part, flow energy, is energy, joule. Second part, potential energy, joule. Third part, kinetic energy, joule. Clear? But for the other equation, it is in head form. Head form. It means each part have a unit of head, have a unit of length. It means first part for B over gamma plus Z, you see, Z, term Z, it means meter. B over gamma plus Z, this meter and this meter, it means the total is meter or feet or inch, unit of length. 1 over 2g v square or v square over 2g, v square over 2g, this unit meter or feet, same, okay? It means I can write the equations in energy form or I can write it in heat form. This energy form and this one heat form. I can write it with another form. Pressure form, for example, pressure form, it means the unit for each term is a pressure. For example, this one, I need to be pressure alone. I need pressure alone. It means I need to cancel gamma. Okay, multiply all by gamma. It means will be go to P plus gamma Z plus, if I multiply gamma here, it means rho v squared over 2 equal to constant. This is the same equation, same like this, same like this. But again, this one energy form, this one heat form, this one pressure form. Okay. Why you study different form? Because some forms is important to be aware and solve the problem is coming to apply by this form direct. For example, many problems solved by heat form, but some special problems is solved by pressure form. It's rarely to use it energy form. Normally we don't use this one, but the default heat form, this is the default one. B over gamma plus Z plus V square over 2G equal constant. Part by part. What is this? This is pressure. Okay, pressure. Units, Pascal. I talk about for SI unit. Pascal. Bridge bound per meter square. Sorry, bound per feet square. Bound force per feet square. Okay, this one, gamma. What is gamma? Gamma is called specific weight. Specific weight. What specific weight? This is equal to rho g. Rho g. One of the property should be studied before in the fluid mechanics, at the beginning of fluid mechanics. It's a term in the part of terms and definition and something like this. Gamma equal rho g. What's gamma? Specific weight is equal to density rho times g, which is gravitational acceleration. Rho is density, is a property. Gamma also is a property. Okay, specific weight. Okay, gamma is specific weight. Unit of gamma, I remember, I think Newton per meter, yes, Newton per meter cube, Newton per meter cube. So in the other side, pound feet per feet cube, pound feet per feet cube. Okay, Z is elevation, okay, altitude. G is gravitational. V is velocity. Gamma is not, I know is not famous, but it is famous for fluid mechanics. As you know, the pressure equation default rho gh, but in many textbook for fluid mechanics and many problems is gamma h. What is gamma? Rho g. Okay. What is the name of B over gamma plus Z? These two terms. What's the name for these two terms? Is bisometric head. Bisometric head. This is the term of B over gamma plus Z. Bisometric head. And we have another name for this. What is this? Static pressure. Static head. Static head. The other part, 1 over 2g v square, it is velocity head. Velocity head. Or velocity head or dynamic head. Dynamic head. It means static head plus dynamic head is equal to total head, which is equal for all points. Same like the pressure. This pressure plus gamma z, this part is barometric pressure. And this one, rho v square over 2, this dynamic pressure. And we can mention this static pressure, dynamic pressure, and this is the total pressure for the point. Total pressure for the point. This energy at point. And this energy at point, the same for each point along the streamline. Okay. Okay. Let me just first clear. Okay, one questions. The Bernoulli's equation is based on the assumptions of. Kindly share with me, please. Azar, hello. Okay, thank you for sharing. Almost. There is no losses of energy of the liquid flowing. Yes. Velocity of the flow is uniform across any cross-sectional of the pipe. Yes, velocity is uniform. No force except gravity acts on the fluid. Yes, also. It means the answer is all of the above. Answer is all of the above. Just 1 minute. I am with you. Just 1 minute. We'll start for numerical problem. Just 1 minute for starting for numerical problem. Numerical problems. Okay. I just open the problem. Okay. I'll share now.
Yes, Rakesh.
Okay. Read first for the problem for 30 seconds. This problem in the exam, typical on the exam, with figure. This figure on the exam from exam type. Finished reading? Okay. Here talk about for flow in a 6-inch diameter pipe is stagnated. Very important this. Stagnated. Answer in this word. Flow in a 6-inch diameter. This diameter for the pipe itself is stagnated at the head of a very fine pore tube as shown in the figure below. Stagnated here. What meaning of stagnated? Stagnated, it means stop. Means the flow, no velocity. No velocity. The water raised to the level 12 inches. For the stagnation pipe here is raised 12 inch. Okay. Above the pipe, another pressure tape in the side wall of the pipe record of water column 2-inch high. Other one here, this one just connected for the duct like this, not with L shape and stagnant flow here, just normal pipe hole, but it is raised by 2-inch. So we have two pipe. One is raised by 2-inch, one is raised by 12-inch. Why? Actually, the required flow rate in the pipe most nearly. Be careful also for this. When he asks for most nearly, it means what you get is not exactly here. We'll find something around. Okay, be careful. Flow rate, it means we need Q. That's it. What's different between this and this? What's different? Actually, focus with me, please. Here, we have two pipe. Normal pipe and L-shaped pipe. For L-shaped pipe, L-shaped pipe, he mentioned the flow is stagnant. It means the flow stopped at this point. Stopped, it means no velocity, no velocity. Okay, so where the kinetic energy go? Energy should be going from form to another, not lost. Clear? Yes. So for the first pipe, just a hole in the duct and the pipe like this type of the pipes measure normally static pressure. Static pressure. For this one here, this one measure what? Static pressure. Okay. But for the stagnation point here, as you see, there is no effect for the flow. Flow is moving, no problem. Okay. But here for this point, no. The velocity stopped. Energy going inside. This energy going inside. Going to where? Is transferred to head. Transfer to head. So this head is part related to what? Related to static default. Same like this, 2 inch. I have 2 inch here. Same like 2 inch is this one. It means this one have static and this one also have static by default for the normal flow. But plus static is also added dynamic part. This is static part. This dynamic part, why dynamic represented here? Because velocity stagnant. Lost. Lost to where? Lost to forever? No. Going to another shape of the energy, going to represent it as a head. Represented as a head. So this part for 12 inch, it is including both static plus dynamic. What is this? Remember the equation for Bernoulli? If you remember, B over gamma plus Z plus V square over 2G equal to constant, correct? It means this part is barometric pressure, which is, I tell you, referred to static part. And this part is referred to velocity head, which is referred to dynamic part. It means this is static head. This dynamic head. This is static also head or pressure. But here is head because this head. And this dynamic plus static. Aha, dynamic plus static. What is this? This is a total. It means this constant is the total, equal to total. Step by step. Step by step. What given here? Given is static alone. Static alone. This part. What is static alone? Static alone is 2 inch. Okay, clear. Plus something equal something. What is the other given? This static plus dynamic. It means this what? This total head. What is this? 12 inch. So what is the missing now? The missing is dynamic head. The missing is what? Dynamic head. From this equation, we can calculate dynamic head. Yes, it is easily. Dynamic head, H dynamic, equal to 12 inch minus 2 inch, which is equal to 10 inch. 10 inch. I have many questions here. What's questions related to problem? A static head is a barometric. Yes, static head is a barometric head. I don't know what is mentioned for link. Internet not connect and not good. Yeah, I'll continue. It means H dynamic is equal to 12 inch minus 2 inch equal to 10 inch. 10 inch. Voice is stable now? Voice good? Yes, dynamic head is half V square over 2G is easy. V square over 2G. V square over 2G. This part is dynamic head. Because I write the equation from the beginning in the head form. This is called head form. I tell you that, yes, for the previous slide. Head form, energy form, pressure form. This one is head form. Okay, it means the first part is barometric head, which is referred to static head, and the second part is dynamic head, which is equal to velocity head. Third part, which is C, is constant or total, this total head. Okay. Now I get the H dynamic, which is 12 inch minus 2 inch is equal to an inch. Okay, what is referred to this one? H dynamic referred to V square over 2G. Okay, it means this one is equal to V square over 2G. Correct. I can get from this equation what? V, direct V. And after I get V, I can get what? Q. What is Q here? Q is equal to AV. Q is equal to AV. This what? This is charge. This volume flow rate. This is charge or volume flow rate is equal to area times velocity. Area times what? Velocity. Okay. This happy face. Remember? Don't forget, please. Q equal AV. Okay. So if I get velocity, I can get the required Q. Okay, from this equation is easy now. What is velocity? Velocity is equal to root 2G 2GH. Till now, easy, no problem. We don't face a problem. We don't face a problem with what? With units. We don't face a problem with units. Okay. Now H with which unit? H. It means bridge. You have to wait. Continue. Bridge or change to SI. Actually, for choices, I don't have the choices now, but actually, for the choices, should be choices here for the exam is given by cubic feet per second. Cubic feet per second. It means bridge unit. It means bridge unit. Okay. So the two way change SI to change British to SI and solve to get Q by SI, and after you get Q by SI, going again back to change it to British. Other way, solve it direct by British. Just check the problem, because each problem it depend on some problems. Sure, need to change it to SI is better. It's cause many difficult conversions, but many problems also is can solve it by SI. Sorry, by British direct. Okay, one by one. What is here? 2 is a constant times G. What is G? Gravitational. 9. If I tell you what is G, all said me G equal 9.81. Yes, it's correct, but this meter per second square. This is not accepted here if I continue by bridge. So we need to use it 32.2 feet per second square. Feet per second square. 32.2 feet per second square. Feet per second square. Now I tell you one of the magic in units, one of the important trick in the exam. I don't see before any exam without this trick. What is this trick? It's a problem coming bridge, but even if it's bridge, we need to change units also again, because it's the units for some variables is not matched. What is G? You save it by feet per second square, correct? Correct. But normally, for all problems given data for the lenses or something like this, for diameter, for lanes, for anything like related for that, by inch. And now you are satisfied. I will continue by bridge. So I change. I don't change any units, and I put G 32.2 and continue. You put in the mistake. Why? Because if you use the inch, it is a bridge, and the other 1 feet, it's a bridge, but not matched. Be careful, please. This is one of the tricks. Almost it's coming for all exams. Okay, H here, 10 inch. means should be changed to feet. It's British, but it changed to feet, which is British also. Okay, 10 divided by 12. Now I change it to feet. Now this value for the height is feet. 10 divided by 12, this feet. You can write it like this, or you can go into the calculator direct, put the select length for the conversion and select it from inch to the feet. Put 10 and get the value for the feet. That's it. Now we can get the value for the velocity with the unit of feet per second, standard for bridge. Feet per second. Feet per second square times feet, we get feet per second. So after we get the velocity, what is the next step? Next step, Q. That's it. Okay, how to calculate Q? Q is equal to A. A is area by over 4 D square stop by over 4 D square V. Actually, the velocity, no problem. I get it here. We can substitute direct. But be careful again. Velocity is feet per second. Diameter. What is diameter? Diameter for the total duct. 6 inch. Inch again. Inch and feet don't mix. Okay? By over 4 D, which is 6 inch, divided by 12 to change it to feet, squared times the velocity. Means by over 4, 6 over 12, squared V. Okay? Now we can get what? Q. What is the unit standard coming from this equation? Cubic feet per second. Okay? Just finally check the unit of the choices. Is cubic feet per second or cubic feet per minute? GBM. But normally it's cubic feet per second. It's enough for the checking units here for different steps. I think it's no need to check again for you for another step for the choice. Okay. This clear or not? This problem is clear for all. This problem is coming with numbers, with figures, with everything in the exam before. One of the famous questions coming. What is the value of G? Is it no, not 9.81. 9.81 for SI accepted, but should be convert to British. Save the other value. Okay, remember, just remind this value 32.2 feet per second square. U, what is UV? You mean V, velocity? Okay, we can mention for this. We can write here. Wait, I just mentioned for calculation. I don't need to remove this page before all is finished. I just make here quick calculation. 2 times 32.2 times 10 divided by 12, it's equal root for this value. Where is root? Yes, 7.3. Velocity is 7.3 feet per second. You can check also by your calculator. This is what I get, 7.3. Okay. After that, you're going to calculation for the Q here. Q, which is equal to area times velocity. Area is by over 4 d square, and velocity 7.3 by over 4 d square, which is 6 divided by 12 to convert it from inch to feet, which is 0.5. That's it. Any more questions for this problem? Okay. Last slide before going to questions and answers. I will make clear now here. I will write it on whiteboard after we finish, and you can take a snapshot. So here, some formula important used for this part. M dot N equal M dot out. M dot is equal rho AV. Qn equal Q out. Q is equal AV. B over gamma plus Z plus V square over 2G equal to constant. Just this formula related for what we discussed today. Okay, not in general formula. No, what we will discuss today. Okay. Now open questions and answers. Mr. Ravi is with us. We can share with us, please, Mr. Ravi. Question and answer.
Okay, Mr. Rakesh, you can unmute and talk.
You can raise, anyone need questions? You can raise hand. I put this mic. Yes. Okay.
Mr. Muhammad, you can unmute and talk.
Mr. J. Muhammad.
Yes, I want to say after getting this value of V, we are substituting in this equation Q, right? Q is equal
after you get V, substitute for the equation of the Q, happy face. V times area.
you calculate the value of 73.3, right?
7.3, yes, feet per second.
Feet per second.
Yes, but check for your calculator.
Yeah.
So
all the values should be in feet. Earlier also you said that you converted this gravitational value 9.81 to 32.2 feet per second.
Because I use G 32.2, the units for this one, feet square per second. Feet per second square. G is feet per second square. Yes. Other way, I used 9.81, but in this case should be changed all to SI, inch to meter, and the diameter to meter, and so on, all SI. And after you get the value meter cube per second for the Q, going back again